Today we're starting Unit 2, Lesson 1. We're going to be talking about relations and functions. So what I'd like you guys to do is title in your journal, Relations and Functions. And right now we're going to do a very, very, very common function. Okay? We're going to write y equals 7.5x. Okay? I want to put x equals hours and y equals buddy. Alright? What do you guys think the 7.5 would represent if x equals hour and y equals buddy? What do you think? An hour, right? So that's $7.50 per every single hour that you work. So if you had a job, okay? Let's go ahead and make a little table here, okay? Put x and y. So you go to your job, you don't work any hours. You work 0 hours right there. You work 0 hours, that means you make 0 money. If you work 1 hour, how much money would you have? $7.50. Now, that's called your gross money. That's before taxes. Alright? Net would be after taxes. So you know that's not what's going to show up on your paycheck. Right? But that's before, that's what you make before you get everything gets taxed. Okay? Now if you work 2 hours, what's that up to? $15, okay? 3 hours, $22.50. Right? And then 4 hours will get you all the way up to what? $30. Okay? Everybody, this right here is an example of a functional relationship. This is a function. And here's what I want you to write down, the definition of a function. A function means each x value has key number 1 corresponding y value. Which means, in a function, each one of these values, known as your independent. So your x values right here, what do we call those? We call those your independent. Your x values are also referred to as the domain. Sometimes teachers say, hey, this is your input. That's what you're plugging in. Right? So, if your x values are your input, then your y values are your output. Okay? If the x values are your domain, then your y values are your range, right? These are the independent, then y is your dependent. These are vocabulary words that you need to be able to have written down, because they're on tests all the time. They ask you for the domain. They ask you for the range. They ask you for what's the dependent variable. What's the independent variable. Alright. So each x value, each input can only have how many outputs? 1. Each input has 1 output. If I plug something into this equation, I should only get 1 result, not 2 different results. Now, everybody, this is considered to be a function. Alright? Now, what's a relation? Any set of ordered pairs. Any set of ordered pairs or an equation. Any equation, any set of ordered pairs is a relation. Everything's a relation. Or any equation. Right? So, in a relation, it could be anything. You could have, alright? You could have an x-axis, a y-axis like this. And I could have a whole bunch of just randomly ordered pairs plotted all over the place. That's a relation. I could just have one ordered pair. That's a relation, right? This right here, everybody, is considered to be discrete. Discrete means they're just dots or points being plotted. Okay? So when you see the word discrete, here's the word I want you to think of. Discrete is, think of just points, ordered pairs, just dots. Okay, on the page. But if I have another graph, right, that looks like this. That's ugly, okay? But you know what? That's a relation. It can look like this. That's a relation. It can look like this. Now these aren't considered to be discrete. These are considered to be what's called continuous. Why do they call these continuous? Because guess what? They continue. And I guess what? If I right here, if I have to go from this point to this point, what do I have to do? I have to jump. Here I can just stay right there on that arrow. Right? So all of these graphs right here, all of these graphs are continuous relations. Not all of them are functions. Right? Because each function has what? Each x can only have one y value. Everything's a relation. So when I say what's a relation, what do you say? Everything. Everything is a relation. Alright, I'm going to write a little statement down here. Okay, I'm going to write this. We'll start here. I'm going to write all functions are relations. Okay, all functions are relations. But not all relations are functional functions. Okay, so I'm going to show you guys a relation that is not a function. Okay, here's a relation that is not considered to be a function. So I'm going to make a little table right here. A little table. Okay. And I'm going to start with what we kind of already did. We had a table that we made in our journal that had 0, 0, then 1, then 7.5. And then it was a 2 and a 15. And 3 and it was 22.5. And then 4 we put a 30. Right now, this is not just a relation, this is also a function. But here's how I can make it into just a relation and no longer a function. If I say a 4, and put a 10. Uh-oh. Look right here. What do we have? We have the same input. Uh-oh. Different output. Would you guys be kind of upset if you had a job, you worked 4 hours and you knew you were going to be getting $30 before taxes, but then you look at your paycheck and you see 4 hours, you get $10? Yeah, wait a second. There's something wrong going on here. Alright, if I work 4 hours, I better get 30. You cannot have different outputs for the what? For the same input and it be considered to be a function. This is not a function. So this was a function until what? Same x value, 2 different y values. So understand, here's what you need to look for. When you're looking for things that are not functions, this is just a what? This is just a relation. So if it's not a function, look for this. Look for repeating x values. Look for repeating x values. X cannot repeat. I don't care what the y's look like. Don't worry about the y's. Alright? Don't worry about the y's. Don't worry about the x's. Make sure that if you have the same x value but 2 different outputs, that lets you know it's not a function. Okay? Alright. Now, everybody, for number 1, okay? These are called ordered pairs, okay? So A and B, everybody, A and B, those are sets of ordered pairs. You guys see this bracket right here? That's just a set bracket. This is a set of ordered pairs. Now, what I want you guys to look for in this one here, if you see any x values that are repeating, you do? Where? Oh, right there. 3 and where? What does that let us know? If you see some repeating, are these the same output or different outputs? Same input but different outputs. So everybody, is this a function? We're going to say no, this is just a relation. When it says explain your reasoning, right? X repeats. Right? X repeats. Understand, we have what? Yeah, but different. You can't do that for it to be a function. So this right here is not a function, it's just a relation. Right? Because remember, but x cannot what? Repeat. X cannot repeat. Right? Now, technically, I guess you can keep plugging in the same x value, getting the same y value as long as it doesn't change. But in ordered pairs, you're not going to keep doing that. Okay? Now let's get over here. Let's look at our x value.
We have the same output.
Wait, you said relation x repeats.
Okay. In the relation, I'm saying, for it to be a function, in a function, x cannot repeat. So it can't be a function, it's just a relation. Okay? So why did I know this was just a relation and not a function? Because x was repeating. We're just saying, in a function, x cannot repeat. Right now.
So you can say output or not input.
That's okay, though. We're just worried about what? We're just worried about the inputs. Are all the inputs different? All right, since all the inputs are different, we're going to write, hey, x did not repeat. So since x did not repeat, this is considered to be a what? Function. Okay? So this is a function because x did not repeat. Each x value, each independent value had one dependent value. Now everybody C and D. This is called mapping. Okay? So if I were to say, hey, I want you to map these ordered pairs, this is what you do to map them. Okay? What I'm going to do, right underneath these, I'm going to give you guys a table that goes with these, okay? So you understand how these right here, everybody, these are all of your x values, these are all of your y values. These are all of your x values, these are your y values. There's your domain, there's your range, domain and range. Okay? Drop a color coordinate real quick. Okay, so right now, here's what I'm asking you. Alright? When you usually you'll see arrows like this. So add some arrows, okay? Can you guys add arrows to the right? Okay? When I plug in a 3, what does 3 lead me to? 3 leads me to a 2. Ooh, what does 3 also lead me to? Ooh. What does negative 2 lead me to? Right. And what does 0 lead me to? Very good. Does everybody see this table that I built? I built this table out of this map. These are called maps. This is mapping. This is a table. So, is this considered to be a function or not a function?
No.
Not a function. What's my evidence?
Because it repeats.
What number? 3.
3.
Ah, so this right here, this lets me know x repeats. It's not good. So this is just a what? A relation. So everybody, this answer for this one, this is just a relation, okay? It's not a function, it's just a relation. Alright, let's go over here, let's go into green. So by the way, whenever you see something, do this. Whenever you see a number, go to 2 different numbers. That's your clue. Have there been algebra tests that have had this question on it? Absolutely. Okay, I've seen this question multiple times on algebra tests. Saying which one of these is just a relation, or which one of these is not a function. Okay? Now, over here, we have a 3 going to a what? And a 4 going to a 2. So what does that mean? That means on this one, I have 3 going 2 and 2, and I have 4 going 2 and 2. What's negative 2 leave me 2? 3. And 0 leaves me 2. Do you see any repeating x values? So guess what? This is considered to be a function. I'm just going to write. Each input has one output. Each input has one output. So that means that has to be a function. Okay? Now I'm going to show you guys some very, very common functions that you guys are going to need to know. Okay? In Algebra 1. So I'm going to show you the 3 functions that you're going to be tested on. Alright, so get your graphing calculators out, and we'll show you the 3 functions we're going to test on you. Let's go. Here are the 3 functions that everybody's going to have to master. Okay? The first one is y equals x. This is called a linear function because it creates a line. So we're going to move lines all over the place. We're going to find slopes and y-intercepts and all that stuff. So this is right here. This is your parent function for all linear functions. Right now, what have you put? Y equals what? Y equals x. And what's that the parent function of? All linear functions. Now, if your graph doesn't look like this, you probably need to hit the zoom 4 button and you can look like mine. Okay? If you have zoom 6, it's going to look like this. Alright? So zoom 4 brings you up nice and close. Zoom. So what kind of function is this? Yes, it is a function. Linear. It makes a line. Yeah, that's easy logic. Alright, y equals x squared. Here's another function. This is a quadratic function. Alright? So everybody, this is y equals what? X squared. And I said this is considered to be a quadratic function. Alright? This is referred to as what's called a parabola. Okay? Now, I want you to notice something. Alright, I'm going to make a little table of values right here, okay? Make a little table of values. You guys see this point right there? That point is at what? Negative 1 and a day, positive 1. What's this point at? Right there. Positive 1 and a day, positive 1. You see how we have the same y value with different x values? That's okay. Does this x value only have one output? Yes. Does this x value only have one output? Yes, so it works. So right up here, that one I'm at a 2 and a what? 2 and a 4. Where am I at right there? Negative 2 and up 4. Notice these are the same. These are different. That's okay. Alright? What we're going to talk about, here's the last function we're going to talk about. By the way, this is a function. This is a function. This is a linear function. This is a quadratic function. Here's the last function that you have to know in Algebra 1. You guys need to know 3 functions, backwards and forwards. Linear, quadratic, and here's the last one, right? Exponential. So, here's what I want you to do. 2, no spaces, what is 2 to the power of x? How do we get to that power? Clear it out. Clear this out. 2. Do you see that little symbol in the calculator right there? The power of x. We're going to graph. By the way, when I said y equals 2 to the power of x, where is that x value located? Up where there's something called a what? Exponent. Everybody, this is called an exponential function. So, what type of functions are you going to be responsible for in Algebra 1? What's the first one? Linear. Second one? Quadratic. Third one? Exponential. Those are 3. Okay? These are all functions. You know what they all pass? They all pass something called the vertical line test, which we're going to do right now. We're going to talk about the vertical line test. Okay? So look at your paper. Go down right here. We're going to look at E and F and G and H. So go right there. We're going to look at your paper. We're going to talk about the vertical line. Alright, before we do the vertical line test, okay, before we do that, let's just evaluate real quick whether these are right. By the way, these are called tables, everybody. If I ever say, make a table, what do I want you to make? I want you to make one of these tables that has what? Like a T-chart. A lot of times they make them like this, where you have X is on one side and Y is on the other. Alright? So right now, is this a function or a relation? What do you think? Relation, why?
Three.
Damn. So this is just a relation. What's your evidence? X is repeating, right? So X repeats. Alright. Over here, does each X value have one corresponding Y value? Which means, do you see X repeating? No. So this is going to be a function. Okay? Now, does everybody remember what I talked about when there's just dots or ordered pairs being plotted on the page? Those are considered to be called discrete, right? What does something continuous look like? This is what continuous looks like, everybody. You see how it's just flowing, continuing to go. Is this continuous? Yes. Is this continuous? Yes. Are these points continuous? No. So let me show you what a vertical line test does, okay? You're going to take a vertical line right now. Each vertical line. You're going to draw a vertical line through that point. You're going to draw a vertical line through that point. Draw a vertical line through that one. Draw a vertical line through that one. How many times does that vertical line touch each of those points? Once. If your line only touches one point, that means it passes the vertical line test. Passes the vertical line test. Which means this is definitely going to be what's called a function. Okay? It's called a function. Now go over here. Alright, does this right here, does this point pass the vertical line?
Yes.
This one?
Yes.
How about this one?
Yes.
Oh, what would be the table? What about that right here? Right there. What X value? 3. So about a 3 and then a 2, and then a 3 and a, no, 3 and a 3. About 3, 2, and about a 3 and a 3. Look what happens. What's repeating? X. So if it touches more than one point, if a vertical line touches more than one point, this is not a function. This is called a discrete relation. This one right here would be referred to as a discrete function. So, listen, before you guys, you still have some time, so don't start putting up. If there are just ordered pairs, it's considered to be discrete. If X repeats, it's considered to be a relation. You can have a discrete function, you can have a discrete relation. But how do you know if it passes the vertical line test or it doesn't? If it hits more than once, it doesn't pass the vertical line test. So here's what I want you guys to write down. The last thing I want you to write down. When you're doing the vertical line test, the line can only pass through once. The line can only pass through whatever it's going through one time. Alright? So understand, if it goes through it more than once, it's not a function. Okay? So let me give you a quick little quiz. Here we go. Is that a function? No, because it does not pass the vertical. It goes through 2 points. So if it goes through anything more. So how about this? How about that? Is that a function? That's a function. Okay? How about this?
No.
Just a relation. It does not pass the vertical line test. Ooh, how many places does this cross? 1, 2, 3. Wow, so anything more than once. Anything more than once, it's not a function, it's just a relation. Your homework, everybody. Your homework is to do 2, 3, and 4. Actually, you know what? Just 2 and 3. That's your homework, 2 and 3.